Welcome to the next module of Sustainable Systems Design, Life Cycle Analysis and Industrial Ecology. Today we will get to the introduction of life cycle assessment, which is one of the key technique used today in sustainability assessment for informing sustainable systems design. In today's lecture, the outline is we'll first go with the basic terminologies used in life cycle assessment, or in short we call it LCA. We'll then go with the LCA introduction, basically defining what this methodology entails, and then we will do a very small thinking activity to draw system boundary. Drawing system boundary is a very key aspect in establishing LCA models, and therefore we will begin with this thinking activity. So, let us get started. Basic terminologies. In any scientific field, when we start to study that field, knowing the nomenclature and the terms that are used is very important. So, we will do the same thing when we start to study life cycle assessment. The first thing that LCA practitioners generally talk about is product. So, what is a product? In general term, product is a useful output or commodity that is of interest to consumers or an industry. Some example of products is manufactured final goods such as pencil, car, packaged medicine, etc. Anything that you can think of that we consume can be classified as product, as long as it is not part of embedded in something else that we are using. Then there are also intermediate goods in the economy, which is something that we probably do not directly use, but it forms an input to the product manufacturing that we consume. So, an example of that is plastic sheet or raw steel. So, we as consumers do not directly consume raw steel, but it forms an component of several of the products that we use. For example, we might be using bottles and the bottle may be made of steel. So, that is an input to the product that we are using. The next terminology that we use in the life cycle assessment is production. So, production is defined as any combination of chemical or physical changes that convert the product material A to another product material B. We might be interested in using material A or material B, but it can be manufactured by combination of several steps. So, the first industry that we talk about is process sectors. Sectors are industrial processes that produces mainly single component substance or mixtures and blends. So, an example of that would be mining process, such as that extracts useful materials from raw ore, both chemical extraction and physical changes such as crushing, or steel manufacturing. So, there are several other examples of process sector. It includes chemical manufacturing or other pharmaceutical manufacturing or raw textile manufacturing. The next definition is the manufacturing sector. Technically, when we talk about manufacturing sector, we are thinking about complex products, and the industries that make complex products from different components are coming under manufacturing sector. So, an example of manufacturing sector as defined in lot of LCA is assembly process in industry, and what it does is that it aggregates various components together to form final products such as car assembly. So, in this what you notice is that there is no transformation of material A to material B, there is no chemical transformation, but what the industry does is it brings together different components and assembles it into a final product that the consumers use. Of course, in this process itself, there is a lot of different aspects that happen. There is input of energy, there is input of perhaps washing and cleaning and joint welding. So, the kind of processes that we talk about in these kind of manufacturing sector are inherently very different than the process sectors which involve transformation of material to A to material B using chemical or physical processes. Another example of complex product is laptop. So, we use lot of us use laptops and computers. and that is manufactured by the electronic industry, but the final step of manufacturing is mostly an assembly process. However, it is very intricate, and if you want to study the life cycle analysis of laptop manufacturing, it will involve really deep knowledge about how these assembly processes are happening. Last is the example is the packaged drug product. So, when we buy medicine finally, it comes packaged into bubble wraps or strips, and that process is actually the assembly process, because the API or the actual drug has been manufactured in the process sector as chemicals, and then it is put together into that packaging form by putting it in the plastic. So, that whole process is a little different and complex, and that comes under the manufacturing of the drug product. So, now we know about product and production. The next terminology used in LCA is system. So, every time you talk to a life cycle analyst, they will talk about system. System is technically defined as a collection of process or manufacturing steps that leads to the product that is of interest. So, all the processes, whether it is chemical, physical, or even the complex manufacturing process, they all can together form a set for the system that we study in LCA. So, when you think about any specific LCA, we think about the whole system, which is an assembly of all of the processes that are going into the manufacturing of that product. Then the last technical term that is used is boundary. So, of course, a system can be very large, but your LCA can be focused on the part of system that you want to study. So, sometimes the goal of the LCA may only be looking at some aspect of the manufacturing. So, you do not want to include all the system components in your study, and that is what is called a system boundary. So, every time when we think of LCA, the first thing we think is definitely what is the system boundary, and in this course we will go into more detail of how do we select the system boundary, what it entails, and how does it make a difference in decision making. So, boundary technically can also extend into other considerations. For example, it can be geographical boundary as well. Sometimes your manufacturing is very distributed, and if you think about supply chains, a lot of these supply chains are distributed. So, you might be manufacturing one part of the whole system component in North India, but you might be manufacturing the next part in South India. And when you want to study the geographical variations as well, that may come as part of your system boundary. Transportation is another aspect. Sometimes we might want to include transportation, sometimes we do not, if we are only focused on the inclusion of main system components. The last thing is also time scale. Lot of the LCA studies would mention the time period for which the study was done. So, not necessarily your manufacturing processes stays the same. So, it might be that in 2010 you had a different impact from one of the manufacturing system, but in 2020 it might be different. So, time scale can be another consideration when we are deciding the system boundary and when we are setting up our LCA system. With that, with the introduction of these technical terms, now we will get into what life cycle analysis is. So, life cycle assessment is a process of compiling and evaluating the inputs, outputs, and the potential environmental impacts of a product system throughout its life cycle. So, what is life cycle? As you can see in the diagram, life cycle starts with the raw materials acquisition. So, when we think about making a product, we start with the raw material acquisition. The next stage is manufacturing of material. So, you take some raw material which is in crude form, let us say an ore form, and you process it to make a material. The next stage is manufacturing of product. If you have a complex product, you might be assembling different components together. The next stage is product use. So, it goes through the use phase, and then the last is disposal, which is the end of life cycle. So, all these stages from raw materials acquisition to manufacturing to product use and disposal is known as the life cycle of the product. So, you can see that throughout each of these stages we can look into depth into very complex phenomena that may be happening at each of the stages. So, when you are modeling a LCA system, you would be considering the details of each of the stages, which will require more engineering knowledge and maybe more operational knowledge about the product use and product disposal and manufacturing. So, when we think of product in LCA framework, it is sometimes more than just a physical product. We can also think of services as a product in LCA. So, one category could be transportation. So, instead of thinking as just one car as a product, we can think of what it is, how many miles it is traveling. So, the actual transportation that happens is a service that the car provides. So, in case of LCA, sometimes we also think of services as the product, and then we model our system as oriented towards providing that service. We can also do an LCA of software. That is very intriguing, because if you think about software is nothing but a piece of code, but when you run a software, you are taking lot of energy, you are also taking lot of input such as a computer system like a supporting infrastructure, and all of this is contributing for the software program to do the job it is defined to do. So, you can do an LCA of software program, but that comes under the service category. Similarly, we can do an LCA of hardware, and of course, the more easy ones are where we are talking about processed materials or conventional product. Among services, we also have tangible and intangible categories. So, tangible product is such as service of automobile, but then intangible is something like income tax statement. Anyone who is providing the service of income tax statement, we can also do an LCA of that service. So, this has become very common in corporate sectors to actually think about their life cycle assessment or impacts of services such as financial auditing or tax preparation. Knowledge transmission is another aspect. So, for example, I am delivering this lecture to you. We can do an LCA or the impact of delivering this lecture to millions of students across through this podium or through this portal, the amount of energy that is taking to record this lecture, the amount of energy that will take to transmit this lecture, and the amount of energy that you will take to consume at the end user. So, all of that can also become a study to understand the environmental impact of this educational initiative. In short, when we think about product in LCA framework, it can be a physical product, it can be services, it can be any activity that we can think of. And as a advanced LCA modeler, it will be upon you to decide how do you set up the system boundary to actually conduct the right LCA that informs each of these tangible, intangible or physical product. With this, we will do a thinking activity for 30 seconds. What you need to do is go back to the definition of systems, you need to go back to the definition of products, and look at the life cycle assessment definition, where you have different stages from raw material acquisition to manufacturing to product use to disposal, and draw a system boundary to do an analysis of a paper cup. So, you know, we all use paper cup, and here our goal is to draw a system boundary that will help us quantify the environmental impact of using a paper cup. So, here you have to think about decision matrix like environmental issue. You can think about what kind of environmental impact you are more interested into. It could be the emissions, it could be the water usage in paper cup manufacturing, or it could be just the disposal. So, while you are doing this activity, keep it simple. Start with the basic building blocks, thinking about products, processes and manufacturing. And if you are very new to this kind of thinking and you do not know what actually happens in paper cup manufacturing, you do not need to worry. Just think about different stages of life cycle and draw this system boundary. Alright, so since you have done this activity, when you are drawing systems boundary, some of the questions that may have occurred in your mind is what are the processes involved? Of course, you would have thought how is paper obtained, how do we make paper cup, how do we transmit or transport it to the users, or how do users use it? How does the products get used and disposed is also can also be a part of your LCA. Some of you might have thought about the raw materials involved. Of course, it is paper, but it could be a recycled paper. It could be a paper that is enforced with new material to give it some color. So, manufacturing of those raw materials depend on what you thought is important in your paper cup study. There could be questions about what are the energy requirements and what are the different impacts and so forth. So, you might have come across a lot of questions. So, let's see what a typical system boundary would look like. One system boundary could be we have a paper manufacturing process. From paper manufacturing, we are molding it into a paper cup manufacturing. So, now from paper, we are just folding it and making it paper cup. And then the third is just the use phase. So, some of you may have thought about these three stages of life cycle for the paper cup. Another system boundary could be this, where we have pulp extraction. So, we are going all the way to the wood where we are doing the pulp extraction and making it into paper. Then we are transforming it into paper cup, then use, and then some of you may have also thought about how do we throw if we are thinking about the whole life cycle of the paper cup. So, the question is that which boundary is right? Is the system boundary 1 correct or system boundary 2 correct? And the answer is that no two boundary will be same. If we start thinking of developing models, we all know that models are very much dependent on how the modeler thinks about developing the model. And one of the key thing is every model is right, but some of them are useful for only certain purposes. So, here also every system boundary is right. No two system boundary will be same, which means that what analysis I did or what analysis you did could be very different. So, how do we tell what is the environmental impact of using a paper cup? We might get very different answers, and that makes it very challenging for decision making. And that is where the life cycle assessment methods come into picture, because it helps us to standardize the framework through which we can do a standardized LCA and we can compare results across different modelers. And that is why we will go through each of the steps of the LCA very much in depth to understand how to do an LCA, a well performed LCA that you can compare with others. So, in LCA there are 4 main steps as defined by the ISO standards. So, the first step is goal and scope, which defines the objective and applicability of your LCA. This is where we define what is the goal of my LCA. So, that makes it very specific for decision making, and the application in the sense that where it is applicable in terms of what data you are using and what kind of system you are modeling. Then there is life cycle inventory. This is where you collect the data for the defined goal and scope. Once you have the goal, the scope, where you have the system boundary, then you would want to collect the data that is relevant for your study. So, that is what we call as life cycle inventory, and this is one of the most critical phase, because if your data is bad, your decisions are going to be bad. So, the simple theory of garbage in, garbage out applies. If your data quality is really bad and you are not confident on the accuracy of the data, you cannot be confident on the decisions you are making on your LCA model, no matter how well done the LCA is. The third step is life cycle impact assessment. In this step, we translate the life cycle inventory into specific impacts. So, when we get to the stage of learning about LCI and LCIA, you will see how to translate LCIA into LCIA. So, LCIA is mainly taking lot of raw data and converting it into meaningful metrics such as climate change impact, global warming potential, ozone depletion potential, human carcinogenic effect, and so forth. And the last stage is interpretation. This is mainly the analysis of results for decision making. This is where we take everything that we have done so far in the first 3 stages and we do different kind of analysis to make decisions. And we will go through some of the examples of what standard methods are for the analysis of the results for decision making. So, what the ISO standards gives, they describe the principles and framework for LCA including goal and scope phase, LCI phase, LCIA phase and interpretation phase, and critical reviews and limitation of LCA. So, since the ISO provides this standard, it is easier for us to follow those norms and then do a standardized LCA that can be compared across different studies. The standard describes the framework and its intended application of LCA and LCIA during goal and scope, but the actual application of your LCA is outside the scope. And also it does not include the details of technique for each phase. However, in this course, we will go through the techniques of each phase in very much detail. With this, in our next module, we will start with the steps of life cycle assessment and we will go through each step with examples so that you can get an in-depth understanding. Towards the end of the course, we will look at a short course project where you will apply these learnings for each of the steps. In this module, we will go through the step 1 of life cycle assessment, which is the goal and scope. So, in this lecture, first we will go through the goal step of LCA. We will quickly see some of the examples of LCA goal statement for different audiences and then we will do a short thinking activity to write down goal statement. Then we will go into the scope phase next. So, step 1, goal and scope. First, goal. The goal of your LCA is mainly the context in which LCA is done or why are you conducting the study. If you have taken any modeling course before, you would have seen that when you develop a model, stating the goal for your model is very important. Are you going to use the model for prediction? Are you going to use the model for assessment or are you going to use the model for control? Based on the goal of your model, the way you set up the model becomes different. Similarly, in life cycle assessment, when we set up the goal, we know that what is the focus of my LCA and what is it going to use for. Based on that, it determines how do we set up the boundary, how do we collect data and what kind of impact assessment and analysis we are going to do. The next thing, which is the scope, in the scope is we are actually making choices concerning the methodology to use in the subsequent modeling. And of course, when we go to the scope phase, we will see that in detail. But what that means is that if you are say modeling a manufacturing process, the methodology could be that we want to look at the whole manufacturing sector together, which can be looking at the economy or you can be looking at just the processes. So, that makes a difference into the modeling that you are going to use down the line. It can also be that you are going to set up a geographic boundary, which is the scoping of your LCA. So, you are only going to focus on a specific geography and that means that let us say we are talking about country A, where the country A is using a technology that is based on renewable energy, while the country B is using a technology that is based on fossil energy. So, that determines that what is the scope of your LCA. So, let us focus on the goal first. What ISO standard says that what goal should be doing is that it shall unambiguously state the intended application, the reason for carrying out the study, and the intended audience. So, I would want to highlight that there are three very important aspects. One is the intended application. Why are you conducting the LCA? How the model is going to be used. The reason for carrying out the study, what is the reason that you are going to use developing the LCA, and the intended audience, which means who is going to use your study. So, intended application is that where it is going to be used, reason is that why are you doing this, and intended audience is who is going to use it. So, based on that you set up your goal statement, and once you have the goal statement set up, then you go for the scoping of your LCA. Intended audience can be very different. So, for example, it can be product developers. So, it could be let us say paper cup manufacturers who are developing the product using new materials. It could be the top management of the company. It could be, for example, a FMCG company who are thinking about sourcing paper cups differently, or it could be customers. So, it could be people like you and me who want to know what is the life cycle impact of me using a paper cup that has been blended with a pigment that gives its red color versus I am going to use the bland yellow one. So, customers can be a different audience for the product. Some of the example of your goal statement is for, let us say we are developing the LCA for product developer. A goal statement could be that the product delivers its function while reducing 30% environmental impact. So, that is the goal of my LCA, that I am going to conduct the LCA for the product and reduce 30% environmental impact through this LCA analysis. Top management could be identifying the hotspots or opportunity for reducing environmental impacts without increasing cost. Customers, the goal of my LCA is that to make a choice between product from company A versus company B. So, we can be buying the same product, but we want to make a choice between company A and company B. So, the goal of LCA would be targeted towards this audience to inform their choices. More specific questions for goals. For product development, it could be that where are the improvement opportunities in the life cycle of product, which means that if you want to develop a LCA for a product developer with this specific question in mind, then specifically looking at each of these life cycle stages and the environmental impact that can be reduced will be one of the key focus. Top management could be more interested in what are the activities with highest impact. So, they could be looking at different stakeholders or the supply chain, and they would be interested in understanding what are the activities with highest impact. Then customers, how do I choose from product from company A versus from company B, and they would be mostly interested in the life cycle impact of product in these two companies. With these specific questions, let us do a simple thinking activity where I would ask you to write goal statements, and your intended audiences are different for each case. So, first we will think about the customer, then we will think about the product developer, and then we will think about the top management. The idea of writing this goal statement is to really narrow down what your LCA could be used for once you have finished the study. So, for customer, the goal of LCA is to inform the customer about the carbon footprint of one unit of the given products for informing choice between product A versus product B. So, product A versus product B could be paper cup which is made of recycled paper, or paper cup which is made of raw material derived from some other forest. So, you could have two different material that is used for making paper cup, and your goal of LCA would be to inform the customer about carbon footprint of one unit of paper from each of those. So, that will help the customers to make a choice between whether they want to use product A which will be made of another material, or product B which is made from some other material. Product developer, The goal of LCA in this case is to inform the product developer about changing manufacturing raw material. So, here again what you would do is that your LCA should be able to highlight the differences between the impact if you change the raw material itself. Changing the raw material could not only mean that you are changing the material input, but also the upstream processes that are making that product. For example, if I am taking a recycled paper for making the product, my input process would be the recycling process. In contrast, if I am going to use the virgin paper from a forest, then that would require me to use the pulp manufacturing process. So, based on what the goal is, we will be modeling the LCAs differently, or we will be choosing the down the stream models a little differently. So, this step of setting up your goal helps us narrow down the scope as we go further in the LCA setup. And the last one is the top management, whose concern is environmental goals of the company. So, in this case, the goal of LCA is to inform the executives about environmental impact of sourcing materials from two different suppliers. And now here you see that instead of just looking at the substitution of material, they will also be looking at the operations of the suppliers. So, if the supplier is, let us say, from country A, which is taking the supply, providing the material through rail transport, versus country B, which is providing the material through ship transport. So, here you now what is important is in your LCA that you would be including the supply chain effects as well. So, as you develop the goal statement, that determines what are the kind of models you are going to include, or what is the kind of system boundary you will be including in your subsequent modeling steps. With this, we will go in the next module and we will talk about scoping of the LCA. So, once you have the goal written, we go to scope step of LCA.